Data reduction techniques are used in the process of data reduction. Data reduction is a step in data pre-processing. In data pre-processing, we have steps like data cleaning, data integration, data transformation, and data reduction. In data reduction is nothing but minimizing the amount of data while keeping the important information in it. It helps in saving storage, speeding up processing, and making data analysis easier. In simple, we can say that removing the unnecessary parts but keeping the important meaning. We can reduce the dimension of data, but it doesn't affect the original data. Why data reduction? Huge amounts of data is being created day by day. Development of big data platforms. Like for day-to-day life, many many data sets are created. Like for example, take as Zomato or Swiggy, who orders like for every customer orders. In dataset, there are many duplicates and all. By removing duplicate data by compressing files, selecting only important features in the dataset, by data deduction, this helps for the analysis easier. Poor performance of old algorithms. Most of the data mining algorithms are column-wise implemented, pushed for data reduction procedures. Data reduction is data reduction techniques are used for the reduced representation of dataset that is smaller in volume and maintains the integrity of original data. In data mining, data reduction techniques are five: dimensionality reduction, data compression, numerosity reduction, discretization operation, data cube aggregation. Let's see one by one. Dimensionality reduction. Dimensionality reduction is nothing but the process of reducing the number of variables on attributes under consideration. Like under one attribute reduces the number of variables in it. There are three methods in dimensionality reduction: wavelet transforms, PCA, principal component analysis. Wavelet transform and PCA both transforms our project original data into small space. It means it reduces the dimension of the data. And the third one is attribute subset selection. This is this makes irrelevant, weakly relevant, redundant attributes or dimensions detected and removed. Like this removes the duplicates or which are unnecessary ones, unnecessary features, and which are not relevant ones. It removes the from the dataset. Example, like in PCA, if the matrix is given, in first step we have to matrix transpose into matrix, and we have to find the eigenvalues and then eigenvectors, and we have to sort the eigenvectors in decreasing order and calculate the principal components in it. And the fifth step, we have to use components for dimensionality reduction. And the other technique is data compression. Data compression is applied so that we can reduce in the name itself, the data is compressed. It means it must be reduced representation of the original data. If original data can be reconstructed from the compressed data without any information loss, then the reduction is called lossless. It is lossless reduction. If we can reconstruct it only an approximation of original data, then the reduction is called lossy. Let's see an example of data compression. This is this is data. This is a sentence in as taken as example. This is data. Data is compressed from the original size. The original size of this is data is 12 bytes, and it compressed into 5 bytes. The more data can be stored, and the data transmission is easier by compression of data compression technique. And the other technique is numerosity reduction. Numerosity reduction techniques replace the original data volume by alternative smaller forms of data representation. It means original data volume, the small it can be represent the data in the smaller forms like bits in intervals. There are two methods of numerosity reduction. They are parametric and other is non-parametric. Parametric methods used to estimate the data. So data parameters need to be stored instead of actual data. Instead of actual data, the data parameters are stored in that place. Example of parametric methods are regression. In regression, linear and multiple are there. And other one is log linear models. And the other method in this is non-parametric methods for storing reduced representations of the data. It stores the reduced representations of the data. Examples are histograms, clustering, sampling, data cube aggregation. Example for the numerosity reduction is like see in these are the blue ones without numerosity reductions and the green checks is like with numerosity reductions. The word length is decreases as compared to before numerosity, and with numerosity the size is decreases. And the other technique is discretization operation. The method of data discretization is used to transform continuous qualities into data with intervals. We use labels for short periods of data time to replace several of the attributes unchanging values. This implies that mining results are presented in a clear and intelligible manner. There are two types of discretization operations. Discretization operation is nothing but like they are given values. It is divided into intervals based on the category, similar category, like signal category. There are two types of discretization, top-down and bottom-up. Top-down discretization is also known as splitting. It is the process of initially considering one or few locations, like breaking points or split points, to divide the entire set of attributes and then repeating this procedure until the conclusion. Bottom-up discretization is all the constant values are first treated as split points. Some of them can be eliminated by combining the nearby values in the interval. Bottom-up discretization is the name of that procedure. Let's see the example of discretization. Suppose we have an attribute of age with given values. There are continuous values of age like 1, 5, 9, and so on and so forth. And table before discretization is like this. After discretization, the age is the age is divided into different intervals. For 1, 5, 4, 9, and 7, for this is categorized as child, and for teenage it is named as young, and for 31 to 46 it is named as mature, and 70 to 78 it is old. And the other technique is data cube aggregation. This technique is used to aggregate. Aggregate is nothing but combining data. Aggregate data in a simpler form. It means the complex data is aggregated into the simpler form. So we can summarize the data in a such a way that the data is used as the result. It means, let's take an example. See here, there are three countries, Canada, India, and USA. They are divided into the states. There are three states for each one, and it represents its profits, gross profit of the states. Instead of Instead of taking these nine columns as states for profits, we can consider as country. There is a unique countries. So we can take for each country USA, India, Canada, and we can sum all the profits of each country. So it reduces the size. So this is nothing but combining the complex data into the simpler form. And let's see data reduction advantages. Improved efficiency. By reducing the data size, leads to faster processing and analysis, saving time and resources. This is nothing but saving time. Easier storage. Smaller data sets require less storage space, making data management more cost effective. Another is better visualization. This helps in the pattern recognition and reduced data size allows for more accessible data visualization. And there are also disadvantages for data reduction. It means if you want anyone which is irrelevant, we have removed it. In that cases, we have to face the consequences. Let's see. In information loss, aggregation and summarization may lead to the loss of some fine-grained details, which could be essential in specific cases. We can remove the information which are not relevant, but in some cases, we have to face like it on. In some cases, it must be essential in specific cases. Another one is selecting appropriate techniques. Choosing the right reduction techniques requires domain knowledge and can be challenging. We have to choose the appropriate technique. Another one is complexity. Implementing reduction techniques adds complexity to the data mining process.